Fine. So let's have a quick review of assignment problem. Now, in case of assignment problem, as you know, there is a square matrix. So number of employee, number of job is there, number of machine, number of tasks is there, the same number of machine and same number of tasks will be there. So suppose 5 machines are there, 5 tasks will be there. Now, how to get the optimum solution in this case? What we do is we start with the row reduction. What is row reduction? Row reduction will select the first row. Suppose there are 5 rows, 5 columns. So we'll take the first row. Out in this first row, we will select the minimum value out of all the values, all the 5 values, and subtract all the numbers from this minimum value. Right. This is what we do row wise. Once the row wise is done, now in the new matrix, after the row reduction, you will go for the column reduction. So we'll do the column reduction same manner. Once row reduction and column reductions are done, now we have to start the assignment. Now what we do in case of assignment? In case of assignment, we will take one condition, a simple condition or a rule you can say. Like if any row or column is having only 1 0, then we will assign. If any row or column is having more than 1 0, we will ignore it at that moment of time, right? So let's start from the first row. So suppose first row is having only one assignment. Sorry, 1 0. We will assign it. And if it is having more than 1 0, we will not assign. We will just ignore. We'll move down to the second. By this way, we'll go for the row allocation, right? So maybe 3 out of 5, 3 allocation will be done, but 2 are still pending. Now we'll go for the row column wise allocation. And again, the column wise allocation, if we have 2 0 in one column, we'll ignore. Now, while doing the row reduction, row assignment, if you assign any 0 in row, you cross that column, which means that suppose employee and job is there. So if you are assigning row 1, first employee, third job, you just cross that column. Means the third job is over, need not to assign to anyone, right? So we will cross. Same way, when you go for column wise, you will cross row wise, right? So column, row wise, right? Now this way you will end up with the all assignments. So you might be having only 4 assignment instead of 5 assignment and all zeros are over. Now this is the condition where you do not have the optimum solution. And in case in 5 by 5 matrix you have 5 assignments, you are basically having an optimum solution, right? So if you have 5 assignment in 5 by 5 matrix, so order will equal to assignment, you will have optimum solution. If you have less than 5, you do not have the optimum solution. Clear? Now, in case if you do not have the optimum solution, so what you have to do is, in case you do not have the optimum solution, you have to do the treatment. How we do the treatment? Now, when you assign, you will basically cross number of rows and columns, right? So in the matrix, if you see, you will find 3 type of values. One value that are on line. Some values will be on line, right? Either this or this. Some value will be on intersection point of the line. Suppose 2 lines are like this. So this is the intersection point. So intersection point. And some value will not be either will not be on line, not at all on line. Right? So some value will not be there on line. Right? Clear? Now, what treatment we will do? We will select the values that are not on line and take the minimum value out of it. So suppose whatever the value, so we'll take the minimum value. And this minimum value, you will first add and subtract. Now, where to add? You have to add to the intersection point. Whatever the value, suppose in the intersection point, there is a value 5 and the minimum value is 2. So you will add this value. So 5 plus 2 is 7. So all the intersection points, you may not have an intersection point. No issue. If you have an intersection point, find the value. If the value is 0, you will add it, whatever the value you will add. And subtract the number from the values that are not at all on line. Right? So all the numbers that are not on line will be subtracted by this minimum. So minimum number, add, and minimum number, subtract. Right? Now in this case, what will happen? You will come up with new matrix. again you have to do the allocation. And this is what you have to do till you find the condition of optimality. And what is the condition of optimality? Condition of optimality is basically where you have to have the order of matrix is equal to the number of assignment. So if your order of matrix is 5, you must have the 5 assignments. So this is a very simple process that you have to adopt. Just focus on it and you'll complete. Fine. So hope this is clear. In my next video, I'll tell you how to solve the salesman problem. Thank you very much.